So if I'm looking for the angle where sine's 1/2, I would go all the way around my circle and find everywhere where my y is a positive 1/2, which is here and here. In radians, those two answers would be pi over 6 and 5 pi over 6. And that's how it would be on your quiz on Monday. Okay, except, that's how it would be on your quiz on Monday. And then the homework also said it in degrees, which is like what you just did on that last test, except now you can use your unit circle. So it would be the 30 degrees and the 150 degrees answers. Yep.
I had a question on where it was -19 pi over 6.
Does it ask you for the 3 trig functions or just the one? Yeah, okay. So again, a good question because it would be something that's on your quiz. So we have 2 options with the negatives. One is just convert it to like your mixed number, plot it as though it's positive, and then fold it like a hamburger to where it overlaps. The other option is I can keep adding 2 pi until it becomes positive. So you can be like, it doesn't matter which of those you choose. They both take about the same thing, especially if you're adding even multiples of pi and not necessarily just 2. Like I can add 2 pi, or I could add 12 pi over 6. And I'd get -7 pi over 6. So I'd want to do it one more time, 12 pi over 6. And I'd get positive 5 pi over 6. So that would be a coterminal angle, but that's also the angle I could use for my unit circle. That's one option. 5 pi over 6 is second quadrant, right? The coordinate point there is -√3 over 2 and 1/2. I would know this by looking at my unit circle. So the cosine is the x, -√3 over 2. The sine is the y, 1/2. The tangent, because we've been smart and memorized my over 6's are √3 over 3, I know it's -√3 over 3 because it would be in the second quadrant where tan is negative.
But the way I did it, I do the mixed number.
So I'll do that next. So then -19 over 6, when I convert that, first of all, I'm going to pretend as though it's positive, then fold it. So I would pretend that it's a positive 19 pi over 6, which is 3 and 1/6 pi. 3 tells you go to the left because that's that's odd. And then 1/6 past it means it's in that next quadrant because it'd be less than the halfway mark. That's if it's positive. If it's negative, I literally fold it like the hamburger, and where it overlaps would be in that second quadrant at the over 6 there, and then it's the same stuff we just did.
So how do you know it's 1/6?
I did 19 divided by 6, which is 3.
No, like, how do you know 1/6 is on the third quadrant?
So the odd tells you right or left, right? So if it was an even whole number, I'd start here. The odd whole number, I start here. And then from there, you either go less than a half and you stay in that quadrant, or you go bigger in a half and you'd go past it to the next quadrant. 1/6 is less than a half. So I know to stop in that first quadrant after the odd. Julie?
If the fraction is 1/2, which quadrant?
You go to the y-axis.
Okay.
Yep. So if it was an even number and a half, if it's 10 and a half, it's this angle up here. If it's an odd, like 11 and a half, it's that angle there. Alaska.
Do you, when you start on the left side, the odd side, do you think that, so you're starting at 0, but on the left side?
You're starting here and you're moving in that direction. So you're still moving counterclockwise as long as it's positive. If you're plotting a negative, that's the only time you'd go the other way.
Okay, because on that side, wouldn't it be pi? Because it starts 0, then it's 1/2 pi.
Yep, and then here's pi, but it's 1 pi. That's the odd part, right? So 3 pi is there, 5 pi is there, 7 pi, that's the odd part. On the right, it's 0, and then it's 2 pi, 4 pi, 6 pi, that's where the even is. Yep.
So whenever it's, so you go counterclockwise whenever it's...
The positive is counterclockwise. Yeah, we go this way.
When it's negative, you go clockwise.
If it's negative, that's one option, is to move to clockwise, or plot it though it's positive and fold it in half.
Okay.
Yep, you could do either one of those.
Thank you.
You're welcome. Okay, so the hard part about today is that it's very different. So you have to kind of shift your mindset that what we're doing today, although not on your quiz on Monday, so I know all of you just went, push it to the back. Okay, it's got to come right back forward because it's on Friday's part. I don't see you Tuesday, right, because of ACT or pre-ACT, which means that we're going to do this today. You're not going to really practice it again until Wednesday, but it is on Friday's test, and this is a really important lesson too, okay? We're going to learn how to graph sine and cosine on an XY axis, not on the circle. These graphs look like this. They look like waves. They go up and down and up and down and up and down and up and down. They do not end. They continue on forever and ever and ever and ever, because your unit circle, you could go around it forever and ever and ever and ever and ever. We will only graph part of a curve. So this is the sine curve, okay? This is one of those things that it is a step-by-step process. I will teach you the step-by-steps, and if you practice the step-by-steps, you will master this, okay? But it is a much more tedious process than like what we're just doing. It's not a quick answer like that, okay? The sine curve, or one period, which means one way full around your unit circle, looks like this. It starts at 0. It goes up to 1. It comes back down to 0. It goes to -1, and it comes back up to 0. And those points come directly from your unit circle. So if you look at where we just plotted points, this is 0. This guy is pi over 2. This is at pi. This is 3 pi over 2. And this is 2 pi. So if I didn't do it the way I'm about to show you, you could always plug in points. The difference is you are plugging in angles. So I'm going to teach you a different way to do it, but this is where it comes from. If you look at the sine coordinate on those 4 spots, here my coordinate point is 1, 0, so the sine is 0. At pi over 2, my coordinate point is 0, 1, so my sine is 1. At pi, -1, 0, my sine is 0. 3 pi over 2, 0, -1, the sine is -1, and then you double back around, and your sine would be 0. Those are these exact points. At 0, it was 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, it's 0. That's where the curve finds its shape. Sarah.
If all those points though are like on the outside of a circle, how come the line looks straight?
Because your x, so on the circle, the value of where you're stopping is your degree, and we're only looking at the sine. So the coordinate point that we get to actually plot the curve, the x is your angle, the y is your sine. So we're ignoring cosine. We pull cosine from the unit circle, those values, but when we're graphing it on our like literal x and y axis, the x-axis is your angles, the y-axis is your sine. So you don't have to do it. Like, we don't have to plug in points. I'm going to teach you a completely different method to do it. But that is where the parent function gets its curve. For sine, at 0, it's 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, it's 0. And that would be one full circle all the way around. That's what's called a period. If I did multiple, so on the bottom you see it says 1 cycle, so 1 cycle's from here to here. A second cycle from here to here. Another cycle back here goes there to there. It is unending. It can continue forever in both directions. But one natural, it's almost like a sideways S, because hopefully that helps you remember the overall shape. It's going to be different when we get to cosine. That's kind of what it looks like. But again, I'm going to teach you a step-by-step process to do this. Cosine, if I did the same thing, if I went all the way around my unit circle and I grabbed the x's of those places, because that's what cosine is, the x coordinate, at 0, I'd get 1. At pi over 2, I get 0. At pi, I'd get -1. 3 pi over 2 would be 0, and 2 pi would be 1. So the curve for cosine dips down and comes back up. If you turn it sideways, it looks like a C for cosine. So sine started at 0, went up, down, down, up. cosine starts at 1, goes down, down, up, up. And again, just like sine, it goes on forever and ever in both directions. All right, here's the first thing you're going to determine. Yeah, basically. So our initial equations, our parent function equations, are going to look like this at the beginning because we're going to learn a little bit more later. But y equals a, and a is going to stand for the value that's on the front of your trig function. Sine or cosine, and then bx. B is the number that's in between the trig function and the x. The a determines your amplitude, A for amplitude. The amplitude is how high and low you go. So the amplitude by definition is half the distance between the maximum values of the function. It is how high up you go from 0 and how low you go from 0. So this vertical distance here is your amplitude. To find that, we do the absolute value of A. So amplitude is always positive because it's absolute value. Our standard one is 1. We go up 1, down 1 again, and up 1 again. If there was 2 on the front of the sign, now I'm going to go up 2 from 0. The second thing you're going to find is the period, and the period is the horizontal distance of one complete cycle, how long it takes you to go from start to finish on one cycle. And we find that by doing 2 pi over b. So amplitude is the absolute value of A. Period is 2 pi over b. Yeah. Okay, so this is our step-by-step process. We are going to step 1, identify the amplitude, which is the absolute value of A. Then step 2, we're going to find the period, which is 2 pi over b. Then we're going to find 5 key points. We're going to take the period, we're going to multiply it times 1/4, 1/2, and 3/4. The first key point is 0. The last key point is the period. So there's a total of 5 key points. Then we're going to plot those key points on the x-axis. So it will look something like this. The first one's going to be at 0. Then it's going to be 1/4 of the period. Then it's going to be 1/2 of the period. Then it's going to be 3/4 of the period. And then it's going to be the period at the end. So on the x-axis, you will have 5 tick marks marked. Then you'll, sorry, go ahead.
Is the P like a variable
Like,
or just like
I just wrote P for period right now. It's actually not an official term. I just got lazy and don't want to write out period every time. Yeah. And then you will mark the amplitude. So if my amplitude is, let's say it's 1, I'll go up to 1 and I'll go down to -1. Let me get a better color there. I'll go up to 1 and down to -1. And then if it's sine, I would start at 0, go up, down, down, up, make my curve. So we'll say purple is sine. And if it was cosine, I would start at 1, go down, down, up, up. It is the exact same steps for both until you get the overall shape at the end. Questions so far? All right, here we go. Step 1 is what? Amplitude and the period. So if I look at this, what is the A? A is 4, which means the amplitude is the absolute value of that, also 4. B is the number in between the trig function and the x. So what is B? 2. So the period is 2 pi over b, which would be 2 pi over 2, which is pi. Good. Sometimes the period has pi in it, and sometimes it doesn't. It doesn't have to. Okay, now we find our 5 key points. I'm going to take pi, and I'm going to multiply it times 1/4, times 1/2, times 3/4. The first one is 0, and the last one is the period, which is pi. So 5 points from here. Again, first one is 0. Second one would be pi over 4. Third one would be pi over 2. Fourth one would be 3 pi over 4. Last one is the period, which is pi. With me so far? Now I'm going to mark all of those points. 0 is the first one. Pi over 4 is the second one. Pi over 2 is the third one. 3 pi over 4 is the fourth one. Pi is the last one. They do not have to be on these grids. They just have to be equally spread out. My amplitude is 4, so I'm going to go mark 1, 2, 3, 4. That's my positive amplitude. 1, 2, 3, -4, the negative amplitude.
How are we gonna know what to do sine or cosine? Because it says in the
Exactly. Good question, because that's the next thing you're doing. Go back, look at your question and say, it's sine. That determines where my points go from here. Sine starts at 0, goes up to the amplitude, back down to 0, down to the negative amplitude, back up to 0. That is 1 period of pi. There are going to be times where it says graph 2 periods of the function. I don't need you to continue to find more key points that are exact. You could literally eyeball the rest of it. Like from your multiple choice, because this is what like the homework looks is multiple choice. You will need to draw this on your work. So everything we just did, you will do on your work. But then when you go to pick from your multiple choice, I would eyeball, and you can go in either direction, but I would continue that curve, either both of those on one side and keep going over here, or a little bit on both sides. It doesn't matter to me. By then you'd be able to pick it out from your multiple choice. And on your test, you'll only have to graph 1 period.
If you did have to find more key points, would it be like the same thing as in the circle, like 5/4?
Yep, so well, if it's pi, you would, every of these is a quarter pi, so you would just keep going up by a quarter pi this time. Yep. So the interval would just stay the same. Questions? All right, we're gonna do it again. So this time it's cosine. You gotta obviously pay attention to that because the overall shape at the end is gonna be different. I'm gonna do the exact same steps. What is your A this time? It's -2, but the amplitude would be +2. What do we think the negative on the front of a graph does? Flips it upside down. Okay, we'll do that at the end though. But if you want to write yourself a note to remind yourself it's got to flip. All right, B is what? 2/3. So the period, which is 2 pi over B, is going to be 2 pi over 2/3. And then we would flip that, 2 pi times 3/2. The 2's cancel, and I end up with 3 pi. So then my first key point is 0. Then it's 3 pi times 1/4, 3 pi times 1/2, 3 pi times 3/4, and the last one would be 3 pi. So obviously 0 stays 0. 3 pi over 4, or sorry, 3 pi times 1/4 becomes 3 pi over 4. 3 pi times 1/2 becomes 3 pi over 2. 3 pi times 3/4 is 9 pi over 4. And the last one, 3 pi. Still good? All right, so first one is 0. Second one is 3 pi over 4. Third one is 3 pi over 2. Fourth one is 9 pi over 4. Fifth one is 3 pi. If you had looked at this graph in comparison with the one we just did already, that entire graph happened before this point, because that's where pi is. So my entire curve was in that section, which means it would appear much skinnier than the other ones. That's how they look, okay? We are spacing these out the same just because we're spacing them out the same, but if you saw those on a grid, one would stretch to be wide like that, and one would be narrower and repeat, so you're gonna see it like that. That's the difference of these on how it would appear if they were on the same number line, okay, or the same coordinate grid. All right, so now my amplitude is 2. I'm going to mark my 2. And if you want to graph it first, then flip it, you totally can, okay? But if I were to graph this first, okay, with my cosine, I would normally start at 2, come down, down, up, and my graph would look like that. God bless you. Be careful not to make it a V. It has to have those soft ends, okay? It has to start to curve around because this would continue this way and this way if I kept going. Now, because it has a negative, instead of starting at positive 2, it would flip. And it would start at negative 2. It would come up, up, down, down. You do not have to graph the first one and then flip it. You could just flip it from the beginning. But know that that last one would be your answer, not the original one. And again, if it wanted more than one period, I would just continue this in both directions or on two sides. I mean, on one side, you could keep going. Noah, do you have a question? Okay. Questions on that one? See if you could do it. All right, so again, you want to note from the beginning that it's sine, which means it's going to start at 0 and then go from there. This time it's a negative sign, which means it's upside down. Your A is negative 1/2. The amplitude is 1/2, which means it's going to be flatter than normal. It's half as tall. Your B is 3, which means the period is 2 pi over 3. The first key point is at 0. The second would be 2 pi over 3 times a fourth. Then 2 pi over 3 times a half. Then 2 pi over 3 times 3/4. And the last one, the period, 2 pi over 3. So this is 0. This becomes pi over 6. This becomes pi over 3. This becomes pi over 2. and the last one 2 pi over 3. So you always want to reduce your fractions if you've got them, and you can. Key points, we're at 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. So it didn't even take to pi for this thing to complete, which means this would be really skinny, really narrow in comparison to the other one. My amplitude, if this is 1, is only at the halfway mark. Sine normally starts at 0, goes up to the half, comes down, goes down to negative a half, and back up again. So my original without the flip would look like that. And again, you can do that and then flip it. Or from the beginning, instead of going up to the amplitude, you can go down, up, up, down, and then make your curve, which should look like that. Yes.
Do you need to reduce the fractions?
Yes.
On the test, do you have to show that it's like flatter?
You would have to mark your amplitude. So as long as you mark your amplitude, even if your like that 1/2 is at 1, it's fine. If you were to, 1, pick from multiple choice, you would want to know that it's flatter. 2, if you said to overlap this on like the initial parent function of sine or compare it to something else, then you should see an adjustment. Yep. Questions? So here's the thing about this homework is that on WebAssign, it is literally multiple choice. On your work, I'm going to nitpick. I am looking for all that work we just did. There are going to be times in which the period duplicates. So let's say you get the same period in 2 questions. You don't have to do all the work for the key points every single time, but you do need to show the key points on your graph. You need to draw by hand on your PDF part of the homework, or if you do it on a notebook, you do have to do that stuff. And then you have to pick from there, okay? All right, I think we're gonna do one more, but we wanna talk about vertical shifts, and then maybe I'll stop for today. So when you add or subtract from your trig function, and there's 2 ways to do it. One way would be inside the parentheses. If this was inside the parentheses like that, what does inside the parentheses usually cause on my graphs? A horizontal shift, right? That would move it left to right, and in sine and cosine curves, we call that a phase shift. We will save that for later, okay? Because you have to shift all your key points. If it is not in parentheses, it is like this, and it could be at the end or it could be at the beginning, like 2 plus sine of x. Those would be the same things. Then it causes a vertical shift. If it's positive, it shifts it up. If it's negative, it shifts it down, just like normal. I do everything exactly the same way we just did, but at the end, I take all my points and I shift them up, or I shift them down. So I literally do it the exact same way, except one more step at the end is to shift all of your coordinate points up or down, depending on the vertical shift. Yep.
Parentheses is horizontal.
Correct. Yep. So you'll see that later. It's called a phase shift in these, but it's a horizontal shift. All right, so we're gonna do this one. That's a lie. Okay, so this one, my A is 1, which means the amplitude is 1. The B is 4, which means the period is 2 pi over 4 or pi over 2. And there's a vertical shift up 1. My key points are at 0, and then pi over 2 times 1/4, pi over 2 times 3/4, times a half. Pi over 2 times 3/4, and then pi over 2. So this stays a 0. This would be pi over 8. This would be pi over 4. This would be 3 pi over 8, and this would be pi over 2. So this would be really skinny because it's happening in just pi over 2, which is like a quarter that it normally does. Then I go to my graph. My amplitude is 1. My key points, 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. And because it's sine, it would normally start at 0. Go up 1, down 1, down 1, and up 1. And my curve would look like that. But the vertical shift up 1 says take all those points and shift it up 1 place. And there's your answer. This one, because I want you to see one with pi in the B. We're gonna do this one. And then we'll go back to that one. All right, so A is what? 1, so my amplitude is 1. B is pi over 4. That whole thing is attached to the x. So the period is 2 pi over 4. And if I flip that, the pi's cancel and I get 8. Your period does not have to have pi in it. I would make a note for yourself to remind yourself that that is a vertical shift down 1 at the end, so you don't forget it, but we don't need it yet. So my first key point is 0, and then it'd be 8 times a fourth, 8 times a half, 8 times 3/4, and the last one, 8. So 4 goes into 8 twice, this is 2. 2 goes into 8 4 times, this is 4. 4 goes into 8 twice, this is 6. And the last one would be 8. First one is 0. Let's say that x-axis was marked with pi and 2 pi. How would 8 relate to 2 pi? Is 8 smaller or bigger than 2 pi? Bigger, because 2 pi is what? 6.28, right? So we would, if this was marked with pi and 2 pi, I would know I'd have to go to the right to the 2 pi to mark the 8, okay? Just so that you can compare the numbers. If it's blank like this, obviously I'm just gonna mark it. 2, 4, 6, 8. Amplitude is 1. It is sine. So we start at 0, we go up to 1, we come down to 0, we go to -1, we go back up to 0. And this is without my vertical shift. So it is not my answer. With me so far? Now I take every single one of those points and I literally shift it down 1 place because it's a shift down 1. So instead of this point being here, I move it to -1. Instead of the next point being at 1, I move it to 0. Instead of the next point being at 0, I move it to -1. The next one's at -1, I move it to -2. The next one's at 0, I move it to -1. I connect those and that would be the answer.
The equation with cosine, would you shift down and then?
So, and that's why I plot it and then shift it. I think it's easier to do that because in your mind with sine, you might be like, okay, I normally start at 0, so I'm just going to go to -1. But cosine gets trickier because you normally start at 1, so you'd start at 0. So it would literally just shift it completely down. And if you have to flip it and shift it vertically, people get really confused. So plot it as though it's not shifted first and then either shift it down or up would be my recommendation. So if it was negative, I would flip it first, then I would shift it up or down. Questions? Okay, we're gonna stop there. We're gonna save that last example and the phase shift for Wednesday of next week, which is crazy, okay? Tomorrow we're gonna focus on your quiz. Monday is your quiz, Tuesday is the pre-ACT, okay? And then we'll come back to this stuff.